Hello, Jiongzhi from Huazhong University of Science and Technology. I'm glad to introduce our team JHLVRP's method for the CVRP program here. Our method is an implementation of the famous HGS algorithm. We denote it as a mathematic algorithm with effective search neighbors, that is MAESN. Actually, our method mainly adds some local search operators into the HGS algorithm. So here, we first introduce the local search process in HGS and then introduce our method. Here are some definitions. U is the node set that contains all the cities or customers. NU is a set that records k nearest cities to the city U. The parameter k is set to 10 by default in the HGS algorithm. Now, let me summarize the local search operators in HGS as follows. That is, HGS traverses each city U belonging to the node set U and each city V belonging to NU to try to improve the current solution by three kinds of operators. They are insert, swap, and to-opt. Here, we present the local search operators. First, I need to note that cities X and Y are the successors of U and V in the current solution, respectively. For each city pair, U and V, HGS tries to use M1 to M9 to improve the solution. We can see that M1 to M3 are insert operators. M1 removes and inserts one city, and M2 and M3 remove and insert two cities. M4 to M6 are swap operators. M4 swap one city with one city. M5 and M6 swap two cities with one city. M7 to M9 are to-opt operators. Moreover, an operator called swap star is also used, which is an efficient swap operator that can find the best swap operator between two different routes quickly. The time complexity of M1 to M9 is order k times the size of U. To clearly show the operators, we provide some simple figures to illustrate. Here are operators M1 to M3 that insert one city U or a pair of connected cities U and X to another place. Yes, the place between V and Y. Here are operators M4 to M6 that swap one city V with one city U or a pair of connected cities U and X. We only introduce the insert and swap operators here because we mainly provide some new insert and swap operators. So we do not introduce the to-opt operator. Now let me summarize the local search operators in HGS. HGS uses these operators to find high-quality local optimal solutions. The efficiency is guaranteed by the applying of candidate sets, that is, NU. The technique of candidate sets is actually widely used, such as LKH and EXJ. And we think that the candidate sets can be used to generate some more effective operators. Next, I will introduce the new operators in our MAESN Solver solver. The new operators need to first traverse each city U in the node set U, then traverse each city V in NU, and traverse each city W in NY. In this way, we generate 6 new operators, 3 insert operators new M1 to new M3, and 3 swap operators new M4 to new M6. These operators can all perform on a sequence of cities, that is, the node sequence from U to W. This results in a larger search scope than the operators in HGS that can only perform on 1 or 2 cities. We believe that the new operators are complementary with the existing operators and can help the algorithm find better solutions. Moreover, the time complexity of the new operators is order square of k times the size of U, which is not very larger than the time complexity of the existing operators. This figure shows the insert operators, new M1 and new M2, where U and W are in the same road. We can see that the city sequence from U and W is inserted between V and Y. The operator new M3 can perform in the situation that U and W are in different roads. This process is executed by changing the connection of the associated cities. And this process can be understood by first transforming the MTSP to the TSP, and then performing the insert operator, finally transforming the TSP to MTSP. Such a technique is also used in the famous solver LKH3. And this figure shows the swap operators, new M4 and new M5, where U and W are in the same road. We can see that the city sequence from U to W is swapped with city V. Similarly, the operator new M6 can perform in the situation that U and W are in different roads. In summary, our solver actually adds 6 new operators into HGS, and the original operators are kept. We believe that the 6 new operators can make better use of the candidate sets to explore in a larger search region without reducing the efficiency too much. And the idea is actually inspired this reference, which uses similar methods to solve the MTSP. That's all. Thanks for your listening.